Hello, so this is a revision video for AP Chemistry 2.5, Lewis diagrams. This is a revision video, so only the essential information is covered. For more detailed explanations and worked examples, please check the links in the description below and visit chemistrystudent.com. Lewis structures or diagrams are a visual tool to represent how valence electrons are distributed in molecules or ions. The main purpose of a Lewis structure is to show which atoms are bonded together and how many bonds exist between them, so whether they are single, double, or triple. We can also show lone pairs of electrons that aren't involved in bonding. When drawing Lewis diagrams, we follow a step-by-step process to ensure that all atoms achieve a stable electron configuration, usually an octet, and the structure reflects bonding as accurately as possible. We count and add up the total valence electrons from each bonding atom. And for polyatomic ions, we add one electron for each negative charge, and we subtract one electron for each positive charge. For example, for a hydroxide ion, because it has a -1 charge overall, we'd have to add one electron to the valence electrons from the oxygen and hydrogen. And for an NH4+ ion, we'd have to subtract one electron, as it has a +1 charge overall. We determine the central atom, which we place in the center of the Lewis diagram. Each single bond that central atom forms to outer atoms contains 2 electrons. And then we distribute the remaining electrons to try and complete octets as much as possible. We start with the outer atoms first, and then place any leftover electrons on the central atom as lone pairs. So for example, with ammonia NH₄, the nitrogen atom has a valency of 5, meaning 5 electrons in its outer shell, and each hydrogen atom has a valency of 1, meaning 1 electron in its outer shell. This gives us a total of 8 electrons. Well, we would have 3 single bonds between the nitrogen and hydrogen atoms, represented by 2 dots, and this would leave a lone pair of electrons on the nitrogen atom, shown as 2 single dots. If when we've done this, the central atom doesn't have an octet, we can try and convert lone pairs from outer atoms into bonding pairs to form double or triple bonds if needed. For example, the molecule O2 has a double bond between the 2 oxygen atoms, meaning 4 dots are placed between the 2 atoms in the diagram, leaving 4 electrons on each oxygen as 2 lone pairs each. Although the octet rule is usually satisfied by most atoms with Lewis diagrams, there are some exceptions. Some atoms, mainly in period 2, can be stable with less than 8 electrons in their outer shell. This would be an incomplete octet. For example, BeCl₂ contains a beryllium atom that only has 4 electrons in its outer shell in the molecule, meaning it is an incomplete octet. Some elements, usually in period 3 or below, can actually have more than 8 electrons in their outer shell. These are exceptions to the octet rule again and are referred to as an expanded octet. For example, in SO2, sulfur actually has 10 electrons in its outer shell. Exam tip here: always remember to count your total electrons before and after drawing your structure. You'd be amazed how many marks are lost every year because students forget to do this step and don't realize they've made a mistake. And remember, for polyatomic ions, add or subtract the correct number of electrons to compensate for the charge of the ion.